Now, this is an introduction to matrices. First question is, what is a matrix? And we can answer that right here. A matrix is a rectangular array of numbers. And we use matrices to display data. So you got rows. We got 3 rows here. We got 2 columns. This is matrix A. Okay? So matrix A is a 3 by 2 matrix. Okay? It's rows by columns. Because it has 3 rows and 2 columns. These dimensions tell us the size of the matrix, and it's important that you put the rows first and the columns second, just for uniformity. All right? Now, usually it's named with a capital letter. O-L or A-L? Anybody know? A-L? Okay. Capital letter. And then, so dimensions of matrix in order, rows by columns. All right, elements of a matrix. Each element or value in a matrix is called an entry. Each entry is written by naming the row and column, row first, column second, in which it lies. This is also known as its address or location. All right, all good on the vocabulary here right now? Element, okay, so notice big B is the matrix, little b is the entry. Okay, little b means it's in big B. Row 2, 1, 2, element 3, row 2, column 3, I should say, is -1. Everybody see that? So when you see this little notation, you're going to go to the 3rd column, 2nd row. Okay? The element 1, 4, 1st row, 4th column is -2. Anybody want to tell me what the entry at B21 is? Colin? You gave me B12.
Oh, so 3.
That's 1, 1.
Oh, 7.
1, 2, 3, 4. 1 and 2. Second. Okay. You may have been right the first time. All right. It is pi. First mistake of the year. All right. So, yes. Colin, I'm impressed and I'm sorry. All right.
If you need to, like Mr. Gilmore just did, if you hurry down, you can do like 1, 2, 3, 4, and then 1, 2. You put R and C, so you remember which one's a row and which one's a column. Please do.
Please remember, the rows come first. Like I just didn't remember. Did I do that? Did I do this one wrong? No, I did that one right. Okay, I'm just. Okay, I did. These I did okay. I'm just inconsistent. All right, so where are we going to put entry 5, the 5? It is B what? Vincent?
B13.
It is. All right. What are the dimensions of matrix B? 2 by 4. Like a board, right? All right. All right, so that's just the entry. Just gives you some of the terminology and the way that things are noted, denoted. Matrix addition and subtraction. You can add and subtract matrices if they have the same dimensions. Okay, so that's a requirement. Same dimensions. Simply add or subtract corresponding entries. Okay? So, do A and C, are they the same dimensions? We're going to add A plus C. They are the same dimensions. So, if I am adding A and C, I'm not going to write A and C out, but I'm going to see if you're understanding this. 7 plus 4.5, and I'll simplify that in a minute. This first row, second column is negative 1 plus 9. Second row, first column is 6 plus 3. This is 0 plus 2.5. This is negative 1 plus 2. And this one is 3 plus 1. And just do each of these calculations. 7 plus 4.5 is 11.5. Negative 1 plus 9 is 8. 6 plus 3 is 9. 0 plus 2.5 is 2.5. Negative 1 plus 2 is 1. And 3 plus 1 is 4. All right? Are we good? Does everybody understand where I got all the numbers as I was looking up here?
If not, please speak up.
Okay, thank you. All right, A plus B. A is a 3 by 2, right? B is a 2 by 4. Can we add A plus B? We cannot. So this is not possible. Different dimensions. All right. Can I do B minus C? No. Again, not possible. Now D minus B. D. D first. Okay? So everybody see we got to follow that order. I'm not going to do 3 minus 12. I'm doing 12 minus 3. First row, first column. First row, second column. 0 minus 9. 1 minus 10. Negative 3 minus 5. Now, I'm in the second row. Negative 4 minus negative 8. Negative 6 minus 7. 2 minus negative 3. 9.5 minus 0. Is that correct? All right. 12 minus 3 is 9. 0 minus 9 is negative 9. 1 minus 10 is negative 9. Negative 3 minus 5 is negative 8. This is negative 4 plus 8, right? Which is 4. Negative 6 minus 7 is negative 13. 2 minus negative 3 is 2 plus 3, which is 5. 9.5 minus 0 is 9.5. Okay, there's my final answer. Everybody understand where each entry comes from? Okay. All right. Multiplying by a scalar. To multiply an entire matrix by a number or a scalar, multiply each entry by that scalar. So it's not like the distributive property. A scalar, I'm going to write, when we're multiplying, it's distributive. Okay? So the result is called something matrix. All right, erase that. All right, the result is called the scalar product. Okay? So, if I do this one, I'm going to try to do it without, I'm going to take 4 times 7 is 28. 4 times negative 1 is negative 4. 4 times 6 is 24. 4 times 0 is 0. 4 times negative 1 is negative 4. And 4 times 3 is 12. Does everybody understand a scalar product there? And then we kind of combine a scalar product with addition on this last one. So what I'm going to do, I'm going to write the scalar product out first. 2 times 3 is 6. 2 times 9 is 18. 2 times 10 is 20. 2 times 5 is 10. 2 times negative 8 is negative 16. 2 times 7 is 14. 2 times negative 3 is negative 6. 2 times 0 is 0. And it's plus this. Can we kind of do this without doing this? Are we at that point, you think? Okay. 6 plus 12 is 18. 18 plus 0 is 18. 20 plus 1 is 21. 10 plus negative 3 is 7. Negative 16 plus negative 4 is negative 20. 14 plus negative 6 is 8. Negative 6 plus 2 is negative 4. 0 plus 9.5 is 9.5. Okay. Any questions? So if you look, we dealt with terminology. And just, you know, how the conventional way of expressing rows by columns, and capital letters are the matrix, the lowercase letters are elements inside the matrix, and these little subscripts are telling us where the entry is. And then we talked about how to add, and they have to be the same size to be able to be added or subtracted, and then scalar multiplication. All right, that's what we wanted to get done today. What I'd like for you to do is practice. There are just 12 questions here that I want you to work on finishing. Okay?